Today you're going to learn about probability, chapters 13 and 14. Here's some formulas and some vocabulary words that you need to be familiar with, so read through those. We're just going to jump straight into the example so we don't run out of time. So here it is. Example 1. Read the scenario. Okay. So for number 1, here's what you need to know. There's actually an official proof that you need for the College Board AP exam to prove for independence. So here's the proof. You just got to write it down with words and everything. So what you'll say is, to prove that two things are independent, you start using words. So for independence, this is a proof. The probability of A, so whatever event A is, has to equal the probability of A given B. This little line is a given condition, and there's a formula for that at the top that we'll talk about. So, for this specific example, I guess let's try it. The probability of A can be any event you choose. So let me read. Well, I guess let's just use event A here that says event A will be the automobile policies, and I guess they're using event H as home policy. So let's start with the probability of auto has to equal the probability of auto given the home policies. So again, that's still part of the proof. So now we're going to fill it in. So find the probability of the person or having an automobile policy, and the question tells you 60% of customers have an automobile policy. So this is going to be 0.6 equals, okay, here's where we're going to need a formula sheet, or the formula that's given at the top, and that's actually a formula that's on the formula sheet, so I will give it to you on test and quizzes. So basically, here's what this formula means. The probability of auto, that little line stands for given home. So what we're going to do for that, we're going to use the formula up there. That's going to be the same thing as the probability of auto and home. This little symbol stands for and. Divided by, you need to divide by the given condition. So notice how this, on the formula sheet, the probability of B, that's the given condition. So we're going to divide by the home, because that was the given condition. So now we just plug in the numbers to make sure that it equals 0.6. So remember, our proof needs to be that 0.6 equals auto and home. So read the question. 25% have both auto and home. So that's 25%. Divided by the probability of home, 40% have home. And now evaluate that to make sure that those are exactly the same. If they are, then it is, they are independent. If not, then they're not. So 0.25 divided by 0.4. So this comes out to be 0.625, which doesn't equal to 0.6. So now you're going to have to tell me, therefore, not independent. And that's the proof that you're supposed to do for the AP exam. I don't think I'm going to ask you that for tests and quizzes because that's really hard, type that up. But you should know it just for the AP exam. Okay, so here's example number 2. And I can post a video for everybody to watch if you want to come back and watch it again. Example 2. Read the scenario so we can see what we're going to do. Alright, so a lot of stuff. Usually what I like to do with these kind of examples, I like to write down what is given for me. So it says the probability that a member picked at random is a doctor is 0.4. So probably a doctor equals 0.4. The probability that a member is a male, 0.5. So probability of male equals 0.5. And the probability that the member is male given doctor. So it's going to be male given would be the little line. Doctor is equal to 0.6. Now find the probability that the member is a doctor or a male. So probability of doctor or male. Male or doctor, doesn't matter. So we're looking for the chances that somebody is a male or a doctor. Doctor or male, the order doesn't matter. So that's actually a formula that you were supposed to do on that first lesson asynchronously. There's a video for you to watch. Go watch it or look at the answer key. But the formula for like A or B, or in this case M or D, is going to be the probability of M plus the probability of D minus the intersection of M and D. That's an intersection. So that's a formula that you do need to know and recognize from the asynchronous lesson. So I guess now we start plugging in everything we know. Probability of male, 0.5. Probability of doctor, 0.4. Probability of male and doctor, we're not sure. We need to figure it out. And the way you're going to figure it out is by using the information that was given and this general formula up here at the top for A given B. So let me use this formula and apply it here. So basically, we have the probability of male given doctor. So the formula for that is the probability of male and doctor divided by the given condition, so doctor. So that's the formula. And we do know that male given doctor is 0.6. We don't know the intersection of male and doctor. Like, that's what we're trying to figure out. So I guess leave it as male and doctor divided by, we do know the doctors are 40%. So if you solve this, cross multiply, you should be able to find the intersection of male and doctor because you multiply 0.6 times 0.4. So 0.24. And that's what I'm going to plug in right there. And now use your calculator to find what are the chances somebody is a male or a doctor by adding male plus doctor minus the intersection. 0.66. So, number 2, final answer, 0.66. All right, example 3. Read the scenario. I like to write down as I read. So 80% of homes in Katy have a desktop. And you can abbreviate just for like all the events, just abbreviate with whatever letter you think makes sense. Laptop. 30% have both. So desktop and laptop. So example 3, what's the probability that a randomly selected home will have a laptop given that they have a desktop? So you're looking for the probability of laptop given desktop. So again, that's that formula at the top is a given condition. You always put the intersection of the two events divided by the condition. So here we'll do, the intersection was 0.3. The condition was desktop, so 0.8. Now we just put that in the calculator. 0.375. On testing quizzes, you can just round to whatever the directions tell you for testing quizzes. Please make sure you round correctly and follow the directions. But that's example 3. All right, example 4. Read the scenario. So for these are kind of challenging, and what's going to happen is you have to practice. Like the more of these you do over and over and over, you'll start recognizing them as solving them with the tree diagram. Obviously you know now because I'm telling you, but you need to practice like the homework. Just keep practicing these, and eventually you'll start recognizing these questions as solving them with the tree diagram. And here's what that means. And obviously, okay, that's not the only way to solve it, but that's what I do. Some of you are like super math geniuses. You can solve it however you want to. That's fine. But I like to solve it with a tree diagram. Here it goes. It says, due to turnover and absenteeism, 20% of the employees are inexperienced employees. So basically, I'm going to start this thing called a tree diagram, and I'm going to put here 20% of employees are inexperienced, so let's just call it I for inexperienced. And therefore, the complement would be 80% of employees are experienced. So put experience. Now it says, management has determined that customers return 12% of the items that were made by the inexperienced employees. So over here in my inexperienced branch, from here I'm going to make another branch, and I'm going to say 12% are returned. Like 12% of items that were made by the inexperienced employees were returned. So put 0.12 returned, and therefore the complement would be 0.88 are not returned. We can just put RC, like that means complement, so not returned. Whereas it says only 3% of items that were made by the experienced people were returned. So over here, my little tree branch is going to be only 3% returned and 97 not returned. You can put not returned, or you can put return complement. So that kind of makes sense. People that are experienced, I guess, do the job better, so there's less chances of being returned versus the inexperienced workers. So now the question says, A, what is the probability that the item is returned? So probability of return. So that's why the tree diagram is helpful for those of y'all that I guess aren't very familiar with probability. So basically, here's how I'm going to get this probability. The chances of an item being returned is going to be this 0.12 times 0.2, because those 12% of the items that were returned were only made by 20% of the employees, plus the other chance of an item being returned is this 0.03, times 80%, because the 0.03% of the items that were returned were only made by the experienced employees. So basically, for a return, here's how you do it. You do 0.12 times 0.2 plus 0.03 times 0.8. And you add up that together to give you the chances of an item being returned. So it helps to draw a diagram for those of you that are new to probability. Some of you guys have been doing like math club and are excellent at probability. You just do it in your head. Just show some work. So I guess for this, it should be, I don't know, 0.0. Let me do it again. 0.048. That is the probability of an item being returned, because it was either returned and made by an inexperienced person, or it was returned but it was made by an experienced person. So that's letter A. Letter B says, okay, if an item is returned, what is the probability that it was made by the inexperienced employee? Okay, so here's the one where a lot of students struggle every year. Like I said, the more you practice these, the more you'll start to recognize them. But basically, letter B is saying, and I put this in my notes on my answer key. Letter B is saying, like, in other words, okay, it's asking you to find the probability that it was made by inexperience. Probability made by inexperience given item was returned. And here's why. So I guess the question says, if an item is returned, so like that's the given condition, like the item has been returned, what are the chances that it was made by an inexperienced person? So again, you just have to practice these so that you can recognize them. So let's try it. Let's find the chances that it was made by an inexperienced person, inexperienced, given that the item was returned. So the formula for inexperience given return should be the intersection of inexperience and returned divided by the given condition, which was the returned, because that's what it said, if the item is returned. So now you look at your tree to find the information. The numerator should be the intersection of returned and inexperience. So returned and inexperience is the 0.12 times 0.2. The denominator should be the return, like what are the chances that the item was returned? And that's what we found on part A. We've already found it, but we did find it by doing 0.12 times 0.2 plus, don't forget the chances of being returned by the experienced worker. So grab the calculator. .5. Example 5. Read the scenario. Oh, yeah, this one you should try by yourself. It's the same thing as example 4. Go ahead and read the scenario. Try it. Alright, so like I said, the more you practice these, the more you start to recognize them. Obviously, I give you the hint for today. Use a tree diagram. According to the scenario, these employees make coffee depending on who gets to work first. So I'm going to start with breaking it into there's a 20% chance that Karen gets to work first, so she'll make the coffee. Or Gail gets to work first, that's 40%, and Larry is 40%. So those are the probabilities that these people get to work first, so they'll be making the coffee. Now, depending on who makes the coffee, there's the probability of them making the coffee bitter. The coffee is bitter when made 10% of the time when made by Karen. So here I'm going to put 2 little branches for Karen. She makes the coffee bitter 10% of the time, so 0.1. And then you put not bitter 90%. Okay, now you do the same thing for Gary and Larry. No, Gail and Larry. Find the chances that they make the coffee bitter. So Gail makes the coffee bitter 20% of the time. Larry makes it bitter 30% of the time. Okay. And now it says, the question, you have to recognize it. If you arrive one morning and find that the coffee is bitter, so like, in other words, given that the coffee is bitter, like that's done, the coffee is bitter, what's the probability that it was made by Karen? Let's do that one first. So the probability that the coffee is made by Karen given that it's bitter. That's what the question is asking. If you arrive one morning and find that the coffee is bitter, so given bitter, what are the chances that Karen made it? You use the formula from the top of today's notes, which says Karen given bitter, you find the intersection of Karen and bitter and divide by the given condition, so bitter. So look at the tree. Karen and bitter is going to be the 0.1 times 0.2, because she makes the coffee bitter 10% of the time, and she makes the coffee 20% of the time, because that's when she gets to work. And now for the denominator, remember you have to think about all of the ways that the coffee could be bitter. So it is going to be still 0.1 times 0.2, or you have to add the other chances of the coffee being bitter. So it's bitter when Gail makes it, or it could also be bitter when Larry makes it. So I need to do Gail, 0.2 times 0.4. And then I need to make Larry, so 0.3 times 0.4. Okay. That's going to give you the correct denominator for the chances of the coffee being bitter. I guess, I don't know, simplify that out. Okay, so if you did do all that, the correct answer comes out to be, the final answer, 0.09, because I divided the numerator by the denominator, and that's the chances that the coffee's, that Karen made the coffee given that it was bitter. I'm going to skip the Larry one because it's the same thing, except for on the numerator you're going to put Larry, so 0.4 times 0.3. I'm going to skip that one. Let me do the one that says, what are the chances that the coffee is not bitter? So for the not bitter, you can look at your tree and do the 0.9 times 0.2 plus the 0.8 times 0.4 plus the 0.7 times 0.4. Or you could, if you already calculated this one here, you can do the complement of that. Regardless of how you do it. Okay, when I found this numerator here, I found that numerator to be 0.22. And those are the chances that the coffee is bitter. So then the chances of it not being bitter are just a complement of that. So probability of not bitter would just be 1 minus 0.22. So 0.78. Pause for questions. Okay, example 6. Read the scenario. So when it comes to these tables, the best thing to do is first find the total for your rows and your columns. So let's find the total for the row of smoking. So add 315 and 165 to figure out how many college students are smokers for 80. And then do the ones that don't smoke. 720. And then do the same thing for the columns. Find out how many drank. 900. And I guess 300 should be the ones that don't drink. Yeah, because there's 1,200 students. So together, the whole thing adds up to 1,200. Alright, so that's the first thing. When you have tables, find the total rows and find the total in the columns, so then you can start answering the questions. Letter A, find the probability that someone in this group smokes. So probability of smokes. That would be the notation you would show. So please show the notation if it asks you for that. I think on the tests and quizzes, you're just typing in the answer after the 0 point. So find the chances that someone smokes. Well, smoking is 480 out of the total of 1,200. I guess it doesn't matter how you leave your answer, but I think on the quiz I'm going to ask for like decimals. So 0.4. Follow directions on how to round correctly. Letter B, find the probability that a student smokes given that he drinks. Given drinks. Okay, here's the thing for that when it comes to tables. So instead of using the formula, the A given B formula from the top, you can use that if you wanted, but that makes it more complicated. If you have a table, here's the easiest way to find a probability given a condition. You want to find the chances of smoking given that the person drinks. So what you do is you only look at the information about drinking. So you only look at the column that has the drinkers. So these are the people that drink. So only look at that information. So now find the chances that they're smoking. So then smoking would be 315. And only do it out of 900 because you only want to look at the drinkers. So again, smoking given drinking is just going to be the 315 out of 900 because I limited the table to only the drinkers, and it's 315 out of 900. That's the best way to find the S given D without using the whole formula. But if that didn't make sense, then use the formula. So type that into the calculator. Okay, you try it with C. Find the chances that a student drinks given that they smoke. Okay, try that. So again, instead of using the formula, if you have a table, it's easier to just limit your table to the given condition. The given condition is given that they smoke, so only look at the smoking row and find out how many of them drink given that they smoke. So you're looking at 315 out of only 480. Just use a calculator. Round to the appropriate place when the quiz tells you what to round to. And finally, letter D is the independent thing. So there's a whole proof that I showed you in example 1, but basically I do ask that on the test and quiz, but you don't have to do the whole proof. You just have to find yes, they're independent or not. So the whole proof, remember, was that for independence, the probability of A has to equal A given B. That was the whole proof. Now you need to pick what you want A to be and what you want event B to be. So I think based on my answer key, it looks like I said event A was the smoking. So then I'm going to do smoking given, and I chose event B to be the drinking. You can choose to interchange them or whatever events you want. So I just said, let's find the probability of smoking. Make sure that it equals smoking given drinking, and if so, they're independent. So I think we already did smoking, 0.4. We already did smoking given drinking, 0.35. They're not the same, so not independent. I think on the test and quiz, you're just typing yes, independent, no, or no, not independent. Just read the directions, yes or no. I think it's actually just yes or no. But that one, no. Alright, so example 7. Read the scenario. So for these kind of questions, the hint is to draw a Venn diagram. Obviously, by the test and quiz, there won't be no hints. You have to figure out what to use, what's the best thing to use. So here it says to use a Venn diagram. So in a Venn diagram, there's a circle for event A. Let's say, I guess, refrigerators. And then there's a circle for event B, which can be the TV. And there's a middle intersection for where they intersect. So what you do is you start with the intersection and work outward. So it says 21% of the rooms have both a TV and a fridge. So right here, 0.21. That's 0.21. Okay, then you kind of start subtracting that intersection from the big circle, so you find out how many have a refrigerator only and how many have a TV only. So basically what I mean is 38% of the rooms have a refrigerator. So this entire circle for refrigerator has to add up to 38%. But we already have 21% in the middle. So do 38 minus 21. That gives me 17. So this, you need to know what it represents. This 17 represents the chances of a room having a refrigerator only. So only a refrigerator, not a TV. 0.17. Do the same thing on the other side for the TV one. Find the chances of having a TV only. And then did I just do this wrong? No, I didn't. Okay. 52% have a TV. So this whole thing needs to add up to 52. Minus 21 is 31. So 31% of the rooms have a TV only. And then to complete the Venn diagram, the whole thing needs to add up to 100%. So right now, if you just add these numbers like 31 plus 21 plus 17, that only adds up to 69%. So that means that 100 minus 69, that means that there's 31% of rooms that don't have a TV nor a refrigerator. So again, the way I got this is I added 31 plus 21 plus 17, and I subtracted that from 100 to get the chances of not having a TV nor a refrigerator. And then that's basically all you have to show for your work, because the rest of that is just analyzing the diagram. Number 7. Find the probability of a TV but not a fridge. I just said it, 0.31. If you don't want to draw the diagram, that's okay. You could just do show your work by doing the on the test and quiz, just because it's online learning. I just ask you to put the answers. But on the AP exam, you would have to show your work with the Venn diagram, or by just doing, I guess, 0.52 minus 0.21 for this. Letter B. Find the chances of a TV or a fridge, but not both. So that would be TV or fridge, but not both. 0.48. And lastly, neither a TV nor a fridge. So there's that number over here. You would have to show your work on the AP exam of where that came from. So remember, that came from doing 1 minus all these little numbers. That's where I got that one from. So show your work. All right, last example, number 8. Read the scenario. Hint, use the table. Here it goes. So basically for this, I'm going to make like a little table, like on example 6. The local animal shelter has dogs and cats. So I guess in my table, I'm going to put the dogs and cats, and then I guess a total. And then male, female. So I guess over here, male, female, and then the totals. Okay. So now you start filling in the table with everything you know. The animal shelter has 24 dogs, 18 cats. 8 of the dogs and 6 of the cats are male. So 8 of the dogs and 6 of the cats are males. So then you should subtract those from the total so that you can find the number of female dogs and female cats. So 24 minus 8, 16. 18 minus 6, 12. And now I can find how many total males there are and how many total female animals there are. So 8 plus 6 is, there's a total of 14 males, and 16 plus 12 is 28. Total of 28 females. And then if you add everything up, there's a total of 42 animals at the animal shelter. That was the hard part, because now that you have that, the rest should be easy to answer. Letter A. Find the probability that the pet is male given is a cat. Male given cat. Again, for the given condition thing, if it's a table, just limit your table to the condition to answer it faster. So male given cat. So that means we only want to look at the cats only. Find the chances that it's a male. It looks like 6 out of the 18 cats are males. So that's what you do. 6 out of the 18 cats were males. Or you can use the whole formula if you want to go the long way. That's like, I guess, 1/3. B. Find the probability that the pet is a cat given that's a female. So for this, we're going to limit the table to only the females. So only look at the female row and find the chances that it's a cat. 12 out of 28. Those are the chances there's a cat given that they're only looking at the females. So type that into a calculator. On the homework, it doesn't matter what you round to, just follow the direction on the quiz. And then finally, the pet is female given that's a dog. Again, only look at the dog part of the table and look for the females. So only look at dogs. Females are 16 out of 24. Okay, so now you have to go and practice your homework and check the answer key.